will see the functions and the modules. So explaining function, we can write a function. Writing a function in any programming, particularly in Python, is very important because we may reuse it, right, by changing the inputs for different parameters. So here an example is forward value is equal to present value times 1 plus interest rate to the power of n. That means just the amount of the future value if you put some money here with the interest rate r, and for n years you'll get the future value to be given by this one. This is a compounding interest rate. So if we want to calculate this one, so the parameters will be here PV, the present value. We have to put the interest rate and the number of years, right? Therefore, here PV times 1 plus r to the power of n will be our function. So you see the def is a key term and the return is also a key term. You see this one is the name of the function. fv subscript f is the name of the function, and this is a parenthesis. These are the argument or the parameters, and this is the return of the function. For example, if you take this parameter present value 10, the interest rate r is 0.1 or 10%. I put this one for 2 years. Then we can calculate the future value. The value of putting 100 birr for 2 years with 10% interest rate will be equal to 121. So this is one example of benefit of using for loop. That means you can change the present value, for example, into 10,000, and if you want, you can change to 7% interest rate and put it this one for 20 years with 7% annual interest rate. After 20 years, 37,696. Alternatively, if the function is very simple, okay, a very simple function, we can use a lambda. That means this is the name of the function here on the left side, and use the keyword lambda, and here are the parameters, okay, p, v, r, and n. Then this is the output. You see, very simple way of writing a function using the lambda. Okay, so the result will be the same as the previous one. So call the function fvf by inserting the parameter 100, 0.1, 10%, and the 2 year. So you'll get 121 will be the answer. So the other thing here is about modules. Modules is simply a file where the functions reside. That means the collections of file or collections of functions. Okay, so the name of the module is usually the file itself. It can be loaded into a program by the following statement. For example, from the name of the module, import star means then we can import all functions which reside in that module. So it is better to look at this one using example. So here an example is very important. Module is called NumPy. Okay, this NumPy is built with a specific goal of handling n-dimensional arrays. All right, you can create matrix, vectors, and so on. So in NumPy there are a lot of functions, right? So we import that function using import NumPy. That means we can say from NumPy import star. That means we import all functions from the NumPy using this one. But conventionally, we use usually this statement, import NumPy as NP. So after that, we will use all function from NumPy using this alias NP, and it is a representation for all NumPy function. Here, for example, when we say A is equal to NP, NP means NumPy. Okay, dot array, that means there is a function inside NumPy which is known as array. That means we can create an array by using this input, which this input is a list. So this inside we have a list containing the entries 1 to 0.5 and the 10. The output will be A. Now it becomes array. So why we get an error? Because we didn't execute here the import. Okay, we have to import first. Now the function NumPy is here, then we will get an array. So what is the type of this variable A? Okay, this variable A is NumPy n-dimensional array, right? In this case, this of course is one-dimensional array. You see, the interesting thing is here, after we create our array, there are different functions on this one. For example, A dot sum means the summation of the entries of the array, right? We can add very simply here, like this one, the sum of the entries, 1 plus 2, 3 plus 0.5, 3.5 plus 10, 10, 13.5. Another example here, there are a lot of functions in n-dimensional array. A dot std means will calculate the standard deviation. Okay, if you have a list of numbers, you can simply obtain the standard deviation by calling std function. Another example, cumulative sum of all element. Cumulative sum of all element, cum sum, that means 1 first 1 plus 2 and so on. So what is the cumulative sum of A will be equal to, it is an array, by the way, it is an array, and it is a cumulative sum. The first element is 1, the second element is 1 plus 2, which is 3, and so on. Another example here, we'll see the main difference of list and array. For example, if you have a list containing 1, 2, and 3, 3 times L means what? Repeat the list 3 times. It is not like vector multiplying the entries by 3. So you see, you will get the repetition of 1, 3, 1, 3, 1, 3, 3 times, right? So, but in the case of an array, you see our array is 1, 2, 0.5, and 3. If you say 3 times A, that means it looks like multiplying a vector, right? It will multiply each entry by the number 3. Also, it can handle that when we say A to the power of 2, that means again it will multiply, or it will make a power of each entry to 2. Now we can use also we can create an array of multiple dimension. Here this is an array of dimension 1, also this is an array of dimension 1, which is the same as A multiplied by 2 for each entry. So the new array will be of this form, which is a 2-dimensional array. Okay, by the way, what is B of 0? B of 0 is the first entry here, which is equal to this one. Now for array, when we say B0 means row, first row, okay, the element on the first row and on the third column. So B is this one, row 1, the first row is indexed by B0, and the element at third column, right? Okay, the first third column means this one, we'll get this one, which is equal to here, right? And when we say b semicolon comma 1 means here all rows, and extract the element in for all rows column number 1. Here all rows column number 1. Column number 1 means column 0. 1 2 is first one, and this one will be column number 1, which is 2 4. You will get 2 4. Again, there is, if you hit this one, you will get the sum of all entries, right? The sum of all entries, all elements in the matrix, but the sum along the first axis can be accessed by assigning x is equal to 0, x is equal to 0, and also the sum along the second axis can be assigned in this way, right? You see this one is, you see what x is equal to 0, that means here we add along this one, 1 1 2 2 6, this one. So when we say x is equal to 1, we add along this, right? One might like to have the n-dimensional array object instantiated first to populate them later. That means we start by 0 or any like ones and so on, then we can populate the numbers. For example, here when you say c is equal to zeros, you see 0, there is a function called zeros in NumPy. NumPy is a module, and zeros takes parameter here, which is, for example, 2 by 3. That means create zeros of size 2 by 3, an array of 2 by 3. Each entry is, in this case, equal to 0. Also, for example, NP wants 3 by 3, that means create a matrix of size 3 by 3, where each elements are equal to 1, as you can see. Also, you can create an element like this one. For example, when you say E is equal to NumPy of zeros of like D, means it will take the dimension of D, but in this case the elements are 0. The dimensions are like D. So when you say this one, it is a 3 by 3 of matrix with entry 0. Another interesting thing, we can create an identity matrix of size anything. Here, for example, F is equal to NP A5 means create an identity matrix of size 5, right? Size 5, like 5 by 5 identity matrix. That means identity matrix where the diagonals are all equal to 1. The other upper and the lower diagonals are zeros. Another very important thing in NP or NumPy is a linear space. That means we can create an array of starting from 0 up to 10, which is equally divided into 10 spaces. Therefore, it is known as linear space. So when you say NP linear space of 0 to 10, that means create a grid of 20, which is equally spaced between 0 and 10, including 10. So, for example, what is the size of, this is a function that means to get an information about G. So, when you say G is one-dimensional array, G dot size means what is the size of G, which is equal to 20. And also there is a function called shape. That means the shape of the n-dimensional array can be obtained by using this statement. For example, it is 20 by it is a vector of length is 20. We can reshape and resize our function for our array. For example, G equal to NP arrange 20. For here, G is equal to, as we said last time, it is from 0 up to 90. That means the first 20 element or the first 20 integer from 0 to 19. Now we can again, this is the shape. You see the shape is just 20 by 1. We can reshape this one into any matrix of any dimension. For example, as far as it is possible, you see the product 4 by 5 is 20. Therefore, we can arrange this one-dimensional array into 4 by 5, which is two-dimensional 4 by 5. So it will take from here the first up to this one, then and so on and so on. You see what we have is, you see here, row 1, row 2, row 3, row 5. Okay, and column 1, column 2, column 3, column 4, column 5. All we can assign this value into h. H is equal to g, the reshape of g, with h is equal to just as we did before. The other thing is about transpose. Okay, transposing a matrix. For example, here the transpose of this one means changing the row into column. Okay, this is achieved by just dot t or dot transpose, actually dot t or dot transpose. Okay, they are the same, changing rows into column and the columns into rows. And we can also resize. Okay, we can also resize our matrix. So it is 4 by 5 matrix. So if we say resize to 5 by 5 matrix, then what will happen? It is 0 to 4 and so on. Then it repeats. Okay, once it completes using all entries, then it start reusing, right, from the beginning. Other function here is stacking. Okay, we have matrix K here, which is 5 by 5, multiplied each entry by 2. Then horizontal stacking and vertical stacking. That means we can put the matrix side by side and create a new matrix which is larger. These are very important, you see. For example, here horizontal stacking of the matrix K and the 2 times K, and put it to a new matrix called L. You see horizontal stacking. So this is, okay, starting from this one, it is a multiplication of 2 times K, and this one is just K. Vertical stacking. This one is vertical stacking, as you can see. Okay, this one is up to this one is K, then this is 2 times K. Also, we can flatten a multi-dimensional array to a one-dimensional array. See here, M is what? M is 10 by 5. Okay, 10 row by 5 matrix. So if we apply M flatten, you will get what? 25. Okay, a one-dimensional array of length 25. You see, one-dimensional array of length 25. Right? Example M dot shape, you'll get 25. M dot flatten shape. What I want is flat dot shape. It is 15 because here it is 10 by 5, which is 15. The other very important module is Pandas. Pandas. It is a library for data analysis with a focus on tabular data. It is a competitive and it is very nice tabular manipulation and data analysis. So in the same way as we did for NumPy, we will import this Panda, and this is conventionally most of the coders use import Panda as PD, and most books also implement importing this way. So the data frame class, the one of the class inside the Panda is a data frame class. It helps us to create a table, right, with column and index. Here is an example. This is the data, right? This is the data as a list. Here is a column. Okay, this is a column, the name of the column, or it is a label of the column. Here is the index. Right, this is an index or value, it is a label, right? So you see pd dot data frame, then these are the input, the data, colons, index is very basic one. Once you run this one, table 1 will looks like the following. You see the colons is numbers, which contains the value 50, 60, and 70, and the index is A, B, C, D, right? So table 1, the index of table 1 is obviously it is A, B, C, and table 1 colon, it has only one colon, which is known as numbers. So when we say table 1, this is a data frame, table 1 is a data frame, dot log means select value corresponding to index C. What is the value corresponding to index C here is 70, you see? That means you can access the value corresponding to an index. So what you have is the following. You see number, which is 17. At the same time, you can take the list of indices like this one, select two values corresponding to the indices A and the D. Okay, you'll get again like this one. Or also you can select the second and the third rows via index position. Okay, index position. This one, the index position 1, that means row 2 up to row 3. Calculating the sum of the single column, we have only one column, so we can obtain the sum again using this sum. Also, we can add new columns to our table. Adding new column to our table, and the name of that column is new here, and the values corresponding to each index is equal to this one. So now the new table will looks like this one. Now we have two columns. Okay, so the new column is here, which is new, with value indicated in this one. So for example, you can access this new the column here. Also, you can calculate the mean. You see, look, the mean of each column. Okay, you will get the mean of the value in each column. The first column is numbers, and the second column is known as new. You will get this one. Also, you can calculate the standard deviation for each columns, like this one. So this is a basic introduction to Pandas data frame. So the next module is here about Matplotlib, which is very important for plotting graph. Here we'll see one example, which is very simple example, but for another video we'll make the extensive use of Matplotlib in plotting 1D, 2D, and 3D plots and other charts. So when we import, and this is conventionally import matplotlib.pyplot as plt, right? So once we import this one, here is an example. T is equal to linear space from 0 to 30. That means create a grid of from 0 to 30 or 10 equally spaced points. Then A is equal to 1000 multiplied by exponent of 0.1 times t. So if we want to plot t versus A here, right, we call plt.plot. Okay, then you will get this plot. Thank you for watching. See you on the next video.